Good afternoon, everyone, and welcome to this lesson on bidirectional thyristors. So in this particular lesson, we will be discussing TRIAC and DIAC in light dimmer circuit. Okay, so at the end of this lesson, the learner shall be able to explain and differentiate the different types of bidirectional thyristors. Next is discuss the basic operation and construction of a TRIAC. And lastly is to explain the different applications of TRIAC such as light dimming, temperature control, and speed control. So shown on the left is the schematic diagram that we will be using to discuss the different thyristors. The first one will be the DIAC. Okay? The DIAC is an acronym which stands for diode for alternating current. Okay, so the characteristics of this semiconductor device is it is a two-terminal device. As we can see here, there are two terminals. This terminal, okay, connecting it to the rest of the circuit, and this next terminal connecting it to the gate of this device. Okay, so it is two-terminal device. It is bidirectional, meaning the alternating current can flow whether it's positive half cycle or negative half cycle. And then letter C is it allows current to flow when voltage supply is greater than the breakover voltage of the DIAC. So we have discussed here a technical specification of a DIAC, meaning this DIAC will only conduct, okay, magpo-flow lang yung kuryente once na the voltage supply will be greater than the breakover voltage. And this is its schematic symbol. So above is the anode 2, and here is our anode 1, or MT1 and MT2, meaning it's main terminal 1 and main terminal 2. Okay? Now, for the equivalent circuit of a DIAC, it is actually composed of two Shockley diodes. Okay, so these are Shockley diodes connected in inverse parallel. As you can see, they are actually in opposing directions. Okay, so right now, it is not simply a diode, but it's a Shockley diode, meaning it has a larger breakover voltage compared to our diode. Okay, as we have discussed previously, if it is silicon, it's 0.7 volts. If it is germanium diode, it is 0.3 volts. But this time, since we are dealing with Shockley diodes, it has a larger breakover voltage. For the characteristic curve, so we have here, okay, since it is a bidirectional device, current can flow in the positive and in the negative half cycle. So for it to conduct in the positive half cycle, it needs to reach this breakover voltage. Okay, once the breakover voltage is reached, okay, the voltage across our DIAC will become smaller, indicating that it has now become a switch. Okay, and then current will rise rapidly. This is what this particular characteristic curve means. And same thing will happen on the negative half cycle. It says here, breakover voltage. Okay, it is the voltage below which a DIAC or TRIAC is not conducting. So kapag hindi natin nalagpasan yung breakover voltage, hindi pa magkakandak yung ating DIAC or TRIAC. Hindi pa nag-close yung switch. But when the voltage surpasses it, conduction starts. So kapag sumobra na sa breakover voltage, then that's the time. Or TRIAC and DIAC will act like a switch. Okay, ito nga yung kanyang characteristic. The voltage across the DIAC will be small, and then the current will rise rapidly. And then the next technical specification of our DIAC that is important is what we call the holding current. Okay, so after a DIAC breaks over, okay, conduction continues. So magpapatuloy yung conduction, magpapatuloy siya ng pag-act as a switch until the circuit drops below this particular value, the holding current. Meaning kapag we are below the holding current, then the DIAC stops conducting or mag-o-open ulit yung switch. Okay? Ganyan yung characteristic ng ating DIAC. Now for the next na bidirectional thyristor, so we have what we call the TRIAC or the triode for alternating current. So ang characteristics naman ito, so this is the TRIAC now on the circuit, and it is a 3-terminal device, meaning may tatlo siya na terminals. We have this terminal connecting it to the DIAC, this other terminal connecting it to our load, the lamp, and this other terminal which is connected to the ground. Okay? So still, this is a bidirectional device, meaning it can allow flow on either of the half cycles, whether it's positive half cycle or negative half cycle. And then lastly, it allows current to flow when gate receives a current. Kung ang DIAC, kailangan is mag-break over muna bago siya mag-conduct. Ito namang TRIAC, kailangan may ma-receive na pulse or trigger current doon sa gate, in this terminal, okay, saka pa lang siya magkakandak or saka pa lang siya mag-a-act like a switch. Okay? That's basically yung function nito. Now for the schematic symbol, we have the schematic symbol of a TRIAC. It's composed of anode 2, MT2, anode 1, MT1, and then the additional terminal, which is the gate. Kung mapapansin niyo dito, class, halos same lang siya ng DIAC. Okay? Same terminals, may nadagdag lang na gate. And this gate, kailangan ng trigger current para mag-flow yung ating kuryente in our TRIAC from anode to anode. And this is its equivalent circuit. So the equivalent circuit for a TRIAC is 2 silicon-controlled rectifiers, 2 SCRs connected in inverse parallel. As you can see here, they are in opposite directions. So ito pa baba, ito naman pa pataas, and then the gates of the two SCRs are actually connected. Okay, so that's the equivalent circuit of this one. So 2 SCRs connected in inverse parallel. Now for the characteristic curve of our, this is actually TRIAC, no? So for the characteristic curve of our TRIAC, we have this one. Kung ang DIAC is meron lang siyang isang breakover voltage, ito, yung TRIAC is iba. Okay, so as you can see here, this is IG1 is equal to 0, meaning without the gate current, it will still be able to conduct through the breakover voltage. Kailangan lagpasan lang natin yung breakover voltage na yan. Pero this is not the best way to turn on our TRIAC, okay, for it to conduct. So merong mas better na way, and that is to introduce a gate current pulse or the trigger current sa ating gate. Ito nga IG2, which is, okay, my value it's greater than IG1, okay, and IG3 is greater than IG2. So this is the ibig sabihin yan. Okay, meaning as the gate current becomes larger, okay, yung breakover voltage becomes smaller. So mas bumababa yung breakover voltage, so mas mabilis na magiging switch yung ating TRIAC. And there will be a rise in current. Okay? Mas mabilis siyang magiging switch since mas malaki yung gate current na introduce. And since this is bidirectional, kung ano yung forma dito, okay, ganun din yung forma ng characteristic curve dito sa kabila. Okay, so ito yung binabanggit natin dito. So the greater the gate current, the lesser is the breakover voltage for a TRIAC. Now, we are already done discussing the 2 bidirectional thyristors. We have the DIAC and the TRIAC. Now, to be able to understand this light dimming circuit, we need to understand the function of this combination of circuit elements here. We have a variable resistor, meaning we can change the value of the resistor. We have this fixed resistor, 5 kilo ohms. Okay? And then we have this capacitor na 0.12 microfarad. Now, as stated here, charging circuit is a combination of a resistor, so meron tayong dalawa, fixed and variable, in series with a capacitor. So we have the resistor in series with a capacitor. Now here we are concerned with the voltage across the capacitor. In this case, we are concerned with the voltage na ma-develop in the capacitor. So as we have already discussed in Electro 1, capacitors are able to store charges. And these stored charges will be creating an electric field, thereby creating a voltage. Itong voltage na mabubuo dito, okay, this will be instrumental in the breakover of our DIAC. Okay? Kailangan malagpasan ng voltage across the capacitor yung breakover voltage ng DIAC para magkaroon ng gate current yung ating TRIAC. Sabi dito, when this voltage exceed yung voltage sa capacitor, when this voltage exceed DIAC breakover voltage, DIAC conducts, and current flows to the gate of the triac, causing its conduction. So, magdo-domino effect. Meaning, kapag nag-charge ito, once it reaches the breakover voltage of the DIAC, this turns on. Once this turns on, so close ang switch, current will flow to the gate, there will be trigger current to our triac, this triac will now close yung switch. And then that's the time mag-flow yung kuryente, thereby turning on our lamp. Okay, so that's basically yung nangyayari dito, the domino effect. Now, one important characteristic of a charging circuit, this one, is how fast the capacitor charges, which can be determined by the time constant. Okay, so yung time constant nga natin, or abbreviated ng symbol na tau, is equal to resistor times the capacitor, or the resistance times the capacitance. So, this is the time constant. Kung mahaba itong time constant, it means na matatagalan bago mag-charge yung ating capacitor, and then matatagalan bago makadevelop ng voltage enough to trigger our, or to break over our DIAC. So sabi nga dito, it takes 5 tau, okay, 5 time constants before a capacitor fully charges. So 5 resistance times capacitance, okay, if we add the resistor times the capacitor, okay, the unit of that will be in seconds, and then 5 times 5 of that, yun yung time na approximately fully charge yung ating capacitor. Okay? So in this circuit, sabi natin dito tau when 5 kilo ohm is present, meaning 5 kilo ohm is present when this variable resistor is in 0%, meaning hindi natin tinurn yung ating variable resistor. So 0 ohm ito. So since this is 0 ohm, so it just acts like a wire. So yung present lang natin na resistance is this 5 kilo ohm resistor and this capacitor na 0.12. So when we calculate the tau, or the time constant, 5 kilo ohm times 0.12 microfarad, the answer is 600 microseconds. Okay, now if i-100% naman natin itong variable resistor, so we have 500 kilo ohm in series with 5 kilo ohm, okay? So we have 505, in-add lang natin yung 500K at 5K, so 505 kilo ohm times 0.12 microfarad. And we have this time constant na 60.6 milliseconds. Okay? Kung titingnan natin, this is 600 microseconds, this is 60.6 milliseconds. So, meron tayong note dito that this means that the capacitor charges quickly if it has less resistance. And the quicker it charges, the quicker the DIAC breakover voltage is reached. So if we take measurements, oscilloscope, and measure the input voltage on this circuit, we will be able to measure this one. This is the 220 volts RMS AC input. So ito yung ma-measure natin dito. Okay? Now, this is the voltage across the capacitor. So this one. Okay? And mapapansin natin, class, there is a spike, spike. And actually, this spike in voltage, that's the time, okay, kung titingnan natin, okay, naka-level siya dito. So there is actually some portion on this one na wala, zero, okay, and then okay, nag-break over yung ating DIAC, saka pa lang nagkaroon ng output voltage. So, mapapansin nyo, class, na yung input natin, okay, kung ito yung input, dito medyo may nakaltas konti. Okay, may nakaltas konti. Nung 5 kilo ohm pa lang yung ating resistor present on the circuit. In this circuit, wala tayong value for the variable resistance, or zero yung value kasi 0%. Hindi natin inikot yung knob. Okay, kaya naman, ito yung kanyang mga voltages na makikita sa oscilloscope. So this is the input. This is the voltage across the capacitor. So once it spikes, meaning the DIAC breakover voltage is reached. Once the DIAC breakover voltage is reached, saka pa lang magkakandak yung ating dito sa ating load. Kaya may part sa input na nawala dito sa output. So medyo nakatipid tayo ng power. Konti. Instead na itong hole yung magpapailaw dito sa bulb, may nakaltas tayo, may natapyas tayo konti. So mapapansin nyo yan dito. There is a small part na nawala sa ating output from our input. Okay? Now, what if we turn the knob to 100%? Okay? What will happen to the waveform? Okay, so go to the next one. Hindi pala, ginawa lang natin class is 95%. Okay, yung pag-ikot natin ng 500K variable resistor. And then this is the voltage waveform. So mapapansin natin dito itong white, hindi lang masyado class, but this is actually white. Yung white is our 220 volts na AC input. So yan yung makikita sa oscilloscope. That is for the input. And then this one, itong orange, this one, this is the charging of our capacitor, the voltage across our capacitor. Pansinin nyo class, from here, inisaka ang voltage, meaning our capacitor is charging. Pagdating niya dito, biglang bumaba, indicating that na-reach na natin yung breakover ng DIAC. Okay? Pagka-attain natin ng breakover ng DIAC, saka palang magkakandak yung ating load. And mapapansin natin yan dito, yung green na kulay. So, panaka-naka yung ating pag-turn on ng bulb. And this is a very small portion of our input. Mapapansin nyo class, ito yung ating input, itong puti. And then ito lang yung output. This part lang. Okay? Meaning at this stage class, medyo itong ating ilaw ngayon is hindi na ganun ka bright, yung kanyang illumination. Hindi na ganun ka lakas. Meaning, napadim na natin yung ilaw. When we increase the value of the resistance, tumaas yung charging time ng ating capacitor. Kung tumaas yung charging time ng ating capacitor, matatagalan bago mag-break over yung DIAC, matatagalan bago matrigger ang TRIAC. At the same time, kukonti yung part ng voltahe na magpapailaw dito sa ating bulb. Kaya naman, didilim. Okay? It will dim. Kaya tawag natin sa circuit na ito, it's a light dimming circuit. Okay? Kung babalikan natin dun sa kabila, kung mas lesser, ito 0%, so meaning 5 ohms lang yung present na resistor dito, mas mabilis yung charging time. Okay? Mas mabilis in microseconds lang. Papapacharge na natin ang capacitor, mas mabilis mag-break over voltage. And that is why, malaking part ng input ang magpapailaw sa ating output. Kaya in this case, this is the brightest na state ng ating bulb. Okay? So from bright, bright illumination dito naman is medyo dim. Since konti na lang yung part ng input na nagpapailaw sa ating output na lamp. So that is basically how a light dimming circuit works. Now this light dimming circuit, this is an application for the light dimming circuit, but it actually pwede din nating gamitin ito for temperature control. Okay, kung dito is bumaba yung kung gaano ka bright or kahayag ang atuang suga. For other applications, pwede din itong temperature control. Pwedeng, this one, during this case, this is a output, meaning mainit. Mainit yung ating output in this case. But if we turn the knob, increase natin yung resistance, then dito naman is hindi na ganun kainit. So we can control the temperature with this particular circuit naman. Provided na ito is no longer a bulb, this is now a heating element. So pwedeng ganun yung purpose nito. Pwede nating application dito class is yung electric stove. Okay, for example, pwede nating mapainit or hindi ganun kainit. Papahinaan yung init ng ating electric stove by using this circuit. So temperature control naman yun. Pwede din na instead of a bulb na load, pwede din na this is an electric motor. Okay? And by varying the resistance here, okay, kung this one is mahina yung pagtakbo ng ating motor, okay, this one is malakas yung takbo ng ating motor, the speed of our motor here. Okay, so speed control naman ito. So again, this particular circuit is pwede nating i-apply whether it's a light dimming, temperature control, or heat control, and then lastly for speed control ng ating mga motor. Okay, and we are utilizing here the two bidirectional devices, the DIAC, which triggers our TRIAC, and a charging circuit. That ends our discussion for this session.